PROHITS carry out proteomics at high temperature for single cells. Can you briefly introduce yourself?
Hello everyone, my name is Mansi Jain and I am the 10th doctoral candidate in the PROHITS consortium. I am currently based in Debrecen, Hungary, where I am conducting my research at the University of Debrecen. I completed both my bachelor's and master's degree in biochemistry from University of Delhi, India. Before starting my PhD, I worked for 3 years in a mass spectrometry-based service providing company as an application specialist in India. I was majorly involved in optimizing different sample preparation workflows to support a range of downstream applications and different analytical objectives. During this time, I gained hands-on experience with several mass spectrometry platforms. Most recently, I was working with the Thermo Fisher Exploris 240 instrument. My background integrates biochemistry, analytical chemistry, and hands-on experience in instrumentation, which now I'm applying to my doctoral research within the PROHITS consortium.
Could you introduce your project and explain your role within the PROHITS framework?
So talking about my role within the PROHITS consortium, so I am majorly focusing on optimizing different sample preparation workflows at the bulk level for different thermophilic species across the PROHITS portfolio. This includes optimization of different cell lysis and protein digestion protocols to ensure that we get the efficient protein extraction, good proteome coverage, and highly reproducible workflow across different organisms. Second part of the project majorly involves optimization of methods to carry out the thermal proteome profiling experiments along with other doctoral candidates stationed at Strasbourg. Further, we will study the melting pattern analysis of microbial strains through TPP, which will help us to study the stability of different proteins and their thermal behavior across different temperatures. The goal is finally to establish a robust and a reproducible workflow that can be applied to thermophilic organisms and to generate high quality proteomics data for supporting other downstream analysis. And finally, my research can support the broader objectives of the PROHITS consortium.
How does your project connect with the work of other DCs?
So, briefly discussing about my connections to other doctoral candidates within the PROHITS consortium. So, I'm working closely with both experimental and the computational DCs. I am working closely with DC2, Josephine, who is based on VUB, and DC8, Anna, who is working in Novoark for the coordination and exchange of cell pellets from different microbial species. Also, since I am the experimental doctoral candidate, so my aim is to give them feedback on the cell pellets we are getting from Novoark and VUP so that we can also optimize the sample preparation. In addition, I will also work with DC6, Dino, who is stationed in the CNRS Strasbourg for the optimization of thermal proteome profiling protocols, which we will also test here at University of Debrecen, Hungary. I am also in close contact with DC4, Kenneth, who is stationed in Norway who will support the downstream data analysis and interpretation of the proteomics data sets which we are generating from these thermophilic organisms, and it will help us to get biological insights from the different experiments what we are conducting.
What secondments or trainings do you have planned, and what are your expectations from them?
So regarding my planned secondments and trainings within the PROHITS consortium, so I have already completed my first secondment at CNRS in Strasbourg. So during this period, I had the great opportunity to work with high-end mass spec instruments, and I also compared the identification between the sample preparation workflows, what I optimized here at the University of Debrecen, and what are already being used in CNRS. My second secondment is planned in Bruker Daltonics, which is one of the industrial collaborators within the PROHITS consortium. So there I am expecting to further strengthen my technical skills, and it will help me to further improvise the different sample preparation workflows which I am working on.
What motivated you to join this project, and what are you most looking forward to during and after your PhD?
So, talking about my motivation to join this project, so I have always been fascinated by biology and wanted to pursue my doctoral studies. And the PROHITS project is a very strong alignment with my previous academic background in biochemistry and my professional experience in proteomics. Another important motivation for joining this project is its highly interdisciplinary and collaborative nature. And within the project, we are working with experts from different domains, including proteomics, microbiology, mass spectrometry, data analysis, and this diversity of experts help us to have a great learning environment and provide continuous opportunity to develop both the technical and the scientific skills. Also, there is a collaboration between the academic and the industrial partner within this project, which gives us a more complete perspective in how research is translated into different practical applications. Also, during my PhD, I'm looking forward to strengthen my expertise in different proteomics workflows, and I would like to have more insight into the data analysis and interpretation, so that I gain more confidence in designing and optimizing different complex experimental workflows. After completing my PhDs, I would like to definitely pursue my postdoctoral research into the same field to further deepen my expertise, and would like to explore opportunities within the industry so that I can apply my skills and get into more practical aspects.
How do you plan to ensure that your project achieves its expected outcomes?
So lastly, how will I ensure that the project achieve its expected outcomes? So I believe in a collaborative project like PROHITS, where multiple doctoral candidates are dependent on each other. An important communication and coordination is important to ensure that we reach the successful outcomes. And one of the key aspects is that I focus on maintaining close and regular communication with all the relevant DCs which are involved in different parts of the workflow. As an experimental DC, I see it as my responsibility to generate high quality and consistent data that can be shared with others in the consortium. At the same time, we actively get feedback from the collaborators regarding the sample quality, the experimental conditions, and the downstream requirements. Another important aspect is flexibility and continuous optimization. In experimental science, especially proteomics, it is very important to keep refining the protocol based on the feedbacks what we get and the results what we are getting. So I try to optimize and troubleshoot the methods to explore alternative approaches whenever needed, and to adapt to different protocols so that they are more reproducible and efficient. Overall, I think that having a clear communication and timely data sharing and getting good feedbacks is one of the key aspects that will help us that the project achieves its outcomes successfully.